In this video, we're going to look at what happens when we have both bending and axial stress acting on a member at the same time. So this is a problem which comes up quite often in structural engineering. And so I've got just a little example here. So say that you've got a beam which is framing into a column. So here I've drawn a steel beam and it's connected on the web through this little shear plate. And when you say it's got some uniformly distributed load applying on it. But, our loads are going to act through the center line of the member effectively. And so if we draw sort of our effective free body diagram, really what, this shear becomes is, we've kind of have a force pushing down on the shear plate with some distance E from the center line. And so if we want to take a force and at some distance and turn it into an equivalent system, well, really what we end up with as an equivalent system is this force coming in from effectively the shear force on the beam, plus a moment which is going to be equal to the shear force on that beam, so the reaction here at the shear plate, and the eccentricity from that shear plate to the centroid. And so, as you can see, well, we have some axial force and some moment. And so if we've got some applied axial force and moment, that means that we will have some internal axial stress and bending stress. And so the way that we deal with sort of calculating these loads or these stresses across a cross-section is we use the principle of superposition. So if the element remains elastic, then we can just simply add up the stresses coming from bending and the stresses coming from axial force. And we know how to calculate both of those. And so conceptually, what that looks like down here is that, if we've got this sort of, bending and axial force acting on the cross-section, well, that's just going to be equal to the bending, the axial force and the bending moment which is applied, which means that we will end up with some stress state, which is, some axial stress plus some bending stress will give us some total stress. And so this is what it looks like in 3 dimensions. On the next page, I have it sort of drawn out, sort of more in cross-section view like we're used to. And as you can see, we're just simply adding up our stresses. So our compression stress here gets much bigger because it's the compressive stress from the axial stress block and the compressive stress from the bending. And it's this value and this value added together. Obviously here our tension gets smaller because it's the axial stress which is in compression and the bending stress in tension. Because these are opposite, they will subtract and it'll get smaller. And so we can really just quite simply just add the two together. So not overly challenging, but a really important concept to sort of lock in. And then we'll explore an example of this in the next video. So thanks for watching.